Hello everyone, welcome to today's webinar. I'm Ada, a data analyst from Team HEARTCOUNT. Our first topic is Introduction to HEARTCOUNT for Data Analysis. I'll be showing you the basic functionalities of HEARTCOUNT, setting the foundation for your journey into EDA. So let's move forward and dive right in. Okay, so let's get started with HEARTCOUNT. Once you log into HEARTCOUNT currently, you'll be accessing the premium version, which offers these advanced analysis features. For those who are on the free public version, there are still plenty of visualization tools available for you. So first of all, we'll use this dataset to highlight the essential data preparation steps for creating a campaign in HEARTCOUNT. Notice that the initial columns here with ordinary numbers. So these NAs signifies the missing values. And the third columns consist of simple categories A, B, C, D. And we also encounter this number-like categories in the fourth and fifth columns, indicating binary variables with values like 0 and 1. Although numeric, these often represent categories such as survey ratings or a 5-point scale. In the sixth column, labeled number in a category, most entries are strings. However, this 1984 stands out. While it appears numeric, we categorize it. And other columns like the date column here represent date variables. In this one, unhelpful variable are repetitive data, which is less beneficial for analysis. And we also have a column riddled with null values. So let's now explore how to introduce a dataset into HEARTCOUNT. Here, you actually have multiple options. Either just drag and drop the dataset onto the interface, or upload it by clicking Browse from your computer. Now for now, I'll just opt for the drag and drop method, followed by a click on Continue to allow the server to process the dataset. So your dataset will appear in a tabular format, similar to the spreadsheet you just saw. And let's take a look at this right here. It says number like category 1. So it's saying that this number like category 1 contains values that could be either booleans or numerics. In this context, so HEARTCOUNT identifies this as categorical. So the presence of ABC means that we're treating this as a category, not a numeric value. And for this column right here, number in a category, those columns here, number like category 2, there's flexibility in how you can define them. Some might be better as categories, while others suits just these numeric representations. But for number like category 2, I'm going to change it to a category variable. And right here, there are two columns which are essentially empty and will be discarded. Yet this one isn't entirely vacant, but holds redundant and unhelpful variables like this. It was all the same, right? So this makes the column less valuable. And if if we go back to numbers 1 column, this reveals an outlier of 20,000 here, one record here. So observing its distribution, most records lie between 0 and 2000, revealing the outliers' distinctness. So this is how our heart count expertly crafts numerous variables, and we can also make some derived variables from the data. And let me demonstrate how this works with both numeric and date variables. So hovering over this number 2 box and selecting customize this column's derived variables reveals default binning and percentiles. So what's binning first? It's a method where you segment a numeric variable into uniform intervals. So here's a glimpse. With the current data set, numbers 2 column, we have here 13 records ranging from 176 to 1011. So these are evenly divided into 10 intervals, each displaying the count of records it encompasses. But now, percentiles work a bit differently. So instead of dividing the data range, they focus on equally distributing the records across intervals. So to clarify, here we have 13 values in total, and 3 of which are NAs. So hence, for the remaining 10 values, we form 5 bins, each aiming to contain an equal number of records. To shed light on interpretation, records within the bottom 20% fall into the 0 and 28th percentile, while those in the top 20% align with the 80 to 100 percentile. If you want to fancy more customization, here's what you can do. Just press plus button and create an additional bin here with 4 bin counts. This is a bin, so I'm going to change this by count to make a percentile. This is how you can make an additional percentile variables with 4 bin counts. I think I've just showed you, but you can also create bins by using custom ranges. You can segregate the values above and below a specific threshold. Let's say 600, like this. So this approach assists in deriving variables to identify patterns or trends, and you can customize it further to suit your needs. So recalling the numbers 1 column, we noted an outlier. So here's how binning handles it. It divides the entire range from the smallest to the largest value into equal parts. So if we aim to segment a range from 0 to 20,000 into 10 bins, each bin covers 2,000 units. Given this approach, some bins might have fewer records. It's actually 0 here. So let's get hands-on. I'll create a binning variable on the fly. I plan to split it at 2,000, forming 2 categories. 2,000, and with values less than 2,000 and those exceeding it. So this process exemplifies how numeric variables can be transformed into categorical ones. So the art of aptly categorizing variables plays a pivotal role in data preparation. So moving forward, let's click continue and start EDA. So as I'm using the public version, everything occurs in browser for now. But by saving the campaign by clicking on this upload this campaign button, the dataset migrates to the server, enabling the use of advanced analysis. Right now, I'm just going to use the public version, which offers robust analytics. But if you want the advanced version, which provides deeper statistical insights, you can consider signing up for a free trial. Okay, so we've primarily focused on data preparation so far, but let's shift to time series data. This data right here represents near hourly electricity usage commencing from January 6, 2016 until 2020 July. So we can discern usage patterns and days of week and distinguish between weekdays and weekends. So to understand how HEARTCOUNT generates date derivatives, let's process this dataset. Here I'll drag and drop our dataset here. Continue. Okay, so the start date right here, this column offers a timeline, and while value in kilowatts show electricity consumption patterns, and the day of week column should be treated as category. Right now it's number, so I'm going to change to category, likely with 0 representing Monday or maybe Sunday. Okay. And the notes column provides context about each entry, such as lockdowns, vacation, weekdays, and weekends. So now let's explore how HEARTCOUNT crafts the derivative variable from a date variable. Start EDA. So while I won't delve deep into smart plots right now, but I'll give you a sneak peek. So starting with HEARTCOUNT's visualization features, particularly smart plot. There's also others, but for now, smart plot. Remember that the y-axis is reserved for numeric variables. And I'll be placing our time series variable on the x-axis. I'm going to change this to sum. In time granularity is very flexible here. You can opt for monthly intervals or weekly, even days and hourly. But this can be quite dense, so for our demonstration, let's stick with a weekly view. Okay. So for further granularity, I'll just put notes in our subgroup. This allows us to slice the data accordingly. We actually have the freedom to alter our visualization here. Let's say to a cumulative stacked area, and you can also change the time range here. Okay, so let's say we're curious about electricity usage patterns across different days of the week. We possess a variable named days of week. So assigning this to the x-axis reveals the electricity consumption for each specific day. An interesting observation here can be, although we begin with a singular date variable, start date, numerous derivatives spring forth. So why so? Similar to how we generated derivatives through binning or percentiles for numeric data, these time series variables undergo a transformation to detect patterns, seasonality, or recurring cycles. So here's a hands-on activity. I'm going to set this to days of week and fetch it as start date, quarters of year, subgroup 2, months of year. So the main takeaway here, should you wish to unearth cyclical patterns, HEARTCOUNT automates the derivative variable creation like this, sparing you all the manual labor. So before wrapping up, let's distinguish between month, your month in the time grain, which is symbolized by this clock icon, and the start date, months of year. It's different. So month under this time grain isn't cycle-centric. Instead, it segments the provided data chronologically, spanning from here January 2016 to December 2020. Here. However, the start date, months of year, isolates the month, overlooking the year. This categorization provides insights into monthly electricity consumption patterns, offering immediate usability. So to sum up, HEARTCOUNT visualization features like Smart Plot allow for diverse analytical views. You can explore data by different granularities such as months, weeks, or even hours. So we've explored data pre-processing in HEARTCOUNT and the creation of derivative variables. Now, I'll introduce you to typical HEARTCOUNT applications using a sample dataset. So jump into New Campaign and select Use Sample Dataset. Okay, and I'm going to pick the Superstore Sales Dataset. Continue. So once in, explore the columns here and their distributions. At its core, this dataset offers insights into sales, capturing details about customers and their purchases, who they are, and where they're from, what they bought, and the size of the products, and transactional specifics, and more. So it's a typical sales data snapshot. Okay, so if you click on this, it says two columns contain values that could be either numerics or categories. We can morph these numeric entries into categories. However, they seem more intuitive in their current form. So I'm just going to leave them and hit continue. Start EDA. Okay, let's uncover some of the HEARTCOUNT's standout features. Okay, I think you'll notice this omnipresent filters atop every navigation menu. These two right here. And currently our data set is holistic. We have this whole data set. But what if we wanted insights solely about office supplies sold in 2015? We can choose the category right here and apply only office supplies and order date by year and select only 2015. and say apply filters. Here, by tweaking the filters, we can isolate and examine these specific 1,217 records out of the whole records. In reverting to our comprehensive data set, it's just a reset away. Press this and apply filters. So while filtering for numerous variables may not always enhance visualization, it can still streamline our focus. If we're only interested in profit, sales, subcategory, and category, you can click apply filters. We can pare down our data accordingly. Yet remember, while this approach might be irrelevant for basic visualizations or smart plots, it becomes pivotal during modeling exercises, especially when cherry-picking input variables for regression analysis. Now let's move on to the menu on the right, which actually overlaps a little bit with the menu on the main panel. Here's an example. I'll put profit on the y-axis and region on the x-axis, and shim mode as our subgroup, painting a picture of average profits per delivery method across regions. And though there's a semblance of redundancy between our top and right menus, the latter here shines with its unique interactivity. Let's change the x-axis here to segment and subgroup to subcategory. In here, you can select the specific data clusters like corporate or home office. Let's filter this. Clear the filter out. Apply again. And we can select them like this. Isolate and reset to revert it. Right now I'm going to select both of them and isolate. Okay, so you can zoom in like this, or even just focus on these records, which stands for copiers here, isolate. Okay, so yeah, this is how you can zoom in to the variables you're interested in. And resetting is just a click away. Okay, so now let's explore the animation feature next. So I'll position sales on the y-axis, and while profit will take the x-axis. And keep in mind that I'm adjusting sales, our sales metric to represent the total, since while profit is typically an average and sales can give us cumulative numbers. Here's the game plan. We'll analyze the data set, focusing on average profit against total sales. And our goal is pinpointing items with both high profits and revenues, and identifying those with lower metrics here, which might not align with the country's strategic focus. Here. So the real magic begins when we introduce the animation feature. I'm going to choose order date, month, and animate our data. So watch closely as the scene progresses month by month, starting from April, maybe 2014. So this will offer an overview of how product profit and sales have evolved over time. I'm going to speed up a bit. So by navigating through the dataset, you can filter and focus on specific variables or metrics to enhance your analytical depth. Okay, so we've navigated the process of importing dataset into HEARTCOUNT and discussed the basics of the navigation menus both on the top and on the right. I've given you an overview, but the core lies in executing the EDA yourself and employing the right visualization techniques to answer specific questions. The depth of this topic requires a more detailed exploration, which we'll cover in a future session. So thank you for joining me today. I look forward to seeing you in our next webinar. Goodbye.